Morning friends, welcome to my YouTube channel. Myself Alpesh Parekh, and today I am going to discuss a very important and the must know topic for the electrical engineer, that why sinusoid is used in electrical engineering. Friends, I have already explained some of the important questions like why 11 kV, 22 kV, 33 kV voltages are used for the transmission line in India. I also make a video regarding the testing of the transformer and some special tests like SFR test of the transformer. You can check the video link given in the description box. Now straight away coming to the topic, why sinusoid is used in electrical. So the most common answer to this question is these two. The first is it is very easy to generate, and second is any repeated signal can be written in terms of sine and cosine by using the Fourier series. These are the most common answer to the above said questions. But friends, both the above statements are not the answer of the question that why we are using sinusoid for the electrical. Why? We all are electrical engineers are knowing that it is not easy to generate a pure sine wave. It is a very difficult task. And as far as the second statement is concerned, any signal can be written in terms of sine and cosine, then why we are using only sine? Why not the other waveform? So these both these statements are wrong. So in this video, I will show you some facts and make you understand that why we are using sinusoid for the electrical. Let's start the topic, why sinusoid. So the reasons are there. First is addition and subtraction of sinusoid is a sinusoid. And second, integration and differentiation of the sinusoid is a sinusoid. Friends, after all mathematical operations like addition, subtraction, differentiation and integration, only the sine wave will remains the same, no other waveform will remains the same. This is the main reason why we are using the sinusoid, right? So you have a question that why I have chosen this for operation addition, subtraction, integration and differentiation. So I will discuss after a few minutes. Before that, first of all understand what is sinusoidal. So this is the equation of sinusoidal. X is equals to xm cos omega t plus alpha, or x is equals to xm cos omega t minus alpha. This is the general mathematical expression of the sinusoidal waveform. Sinusoidal doesn't mean that only sine omega t is a sinusoidal waveform. Cosine wave, shifted cosine or the sine, all are the form of sinusoidal, right? So the students have difficulty in understanding that what is the sinusoid, right? Now I will show you some of the operations on the different signal. Now look, this is the waveform of a square. Here this is one square wave, here another square wave. Now when we add two exactly similar square waveform, we will definitely get a square wave. But what happens when there is a phase shift in the one of the waveform? This is the one square wave and I have shifted this square waveform. So the output will be get distorted. Now this is the addition of two triangular waveform. The same way, when we add the two exact similar triangular waveform, look at here. Here the peak is here the peak is here. So when I am adding to similar triangular waveform, I will get the similar triangular waveform itself. Now, when we shift one of the triangular waveform, look, this is the triangular waveform. I have shifted this waveform. So this output will get distorted, right? Now, as far as the sine wave is concerned, now when we add to exactly similar sinusoidal waveform, we will get the same sinusoidal waveform, right? Now, suppose I am shifting the sine wave. Here the output is also remain the same, but magnitude is also changing, but the shape of the waveform remains the same as the sinusoidal. Now, when we integrate or differentiate the square wave, what happens? This is the square wave. So I will get the triangular wave shape after integration, and I will get this pulses like signal after differentiation. So ultimately, the square waveform is deformed and the output is distorted, right? Now what happened to the triangular waveform? When the input is triangular, now I will integrate, I will find a sinusoidal waveform. And if I will differentiate, I will get the square waveform, right? Now coming to the sinusoidal waveform. When we integrate or differentiate the sinusoidal waveform, it does not lose its shape. Now you have a question that why I have mentioned about these four operations: addition, subtraction, differentiation and integration. So friends, in the electrical engineering, we are mainly dealing with the resistor, inductor, capacitor and the electrical power sources, right? So this is the resistor, inductor and capacitor. Now this is the sum of the relation in between voltage and the current. So here V is equals to I into R. So we can say that I is equals to V by R. In the inductor, V is equals to voltage across inductor is equals to L di by dt. I can write another way, I is equals to 1 upon L integration of V into dt. Now in the capacitor, I is equals to C dV by dt. The same way I can write here V is equals to 1 upon C I into dt, right? So you can see from this equation that mainly the differentiation and the integration is coming into the picture. Now also understand as far as the transformer is concerned. This is a transformer, right? So here what happened? Here also the differentiations of the signal is coming to get the output voltage. So what happened if I have to transfer some power, I have to differentiate the signal. So suppose I am using a square wave as an input. This is the input signal. Suppose I am giving this square wave, then what happened? After differentiation, this signal will become like this. It's a pulses, right? So no use. Now, instead of square, if I am giving the sine wave, look at here. But if we use the sine wave, then after integration or after differentiation, the sign will remain the same. So the sine wave will remain the same. The shape is not changing. So this is the advantage of the sinusoid. Now I have talked about the differentiation and the integration. So your question that why addition and subtraction? So simply it is due to the KCL and the KVL, Kirchhoff current law and the Kirchhoff voltage law, because this is the circuit of the series RLC circuit. This is series R, L and C. Voltage across resistance, voltage across inductance and voltage across capacitance. Now I have to get these results, so I have to add or subtract any other signal, right? But suppose I am adding or subtracting the signal except sine wave, then what happens? As I have discussed, as I have shown the different operations, the output will be distorted and we are getting not the sine wave as output. So that is why I have mentioned four mathematical operation: addition, subtraction, differentiation and integration. After all four operation, the sinusoid is the only wave which will remain sinusoid, right? So what is the conclusion of this lecture? The conclusion is addition and subtraction of the sinusoid signal results in the sinusoid. That is the most important thing. Second, integration and the differentiation of the sinusoidal result in the sinusoid signal. So that is why sinusoid is the only signal that can remain same in the shape, though there is a change in the magnitude. So that is why this is the main reason why we are using sinusoid in the electrical power systems. So I hope friends you have understand the topic and you have learned something new in a better way. Please like our video, share the video and give your valuable comments. Thank you. Keep watching, keep learning.